So, welcome back to Miss B Makes It Easier, and we're doing a whole other graph, and just follow along. So, a student conducting an experiment on light traveling from glass to air. Figure 1 is a diagram showing light traveling from glass to air. The results of the experiment are recorded in table 1. And so this is experimented, so you would draw it. This is the glass, this is the air, and when light, if you've never done this experiment before, you don't know what we're talking about. When light travels from a very dense medium to a less than dense medium, it travels faster. So in here it will travel slower, and when it comes out it will travel much faster. Okay, and so the angle of refraction is always made from the ray towards the normal. So this is a normal right here. So let me write the word normal right here. Okay, so as that is happening now, this is set. So here you have the angle of refraction, 10, 30, 50, 70, and 80. And at the same time, so this is the angle of refraction here. At the same time, the angle of incidence was measured, which is in here, right? So the angle of incidence is 6.5, 19, 30, 38, 41. Now, we're told to fill this in. So you have 10 spaces to fill in, and they tell you exactly what to do. The sine of the angle of incidence. So to do that, you just take your calculator and you start. So here goes. You want to find the sine of I. So we're doing this column first. So sine, there we have sine 6.5 equal to 0.1. And what we're going to do is, since everything here has just one decimal place, we're going to put just one decimal place over here. All the answers are going to be to one decimal place. So 0.1, and then we do sine 19, 0.3, sine 30, 0.5, sine 38, 0.6, and sine 41, 0.7. So there we have our first column. Okay, now we're going to do the sine R. Oh, I did the wrong one. This is sine I. Okay, so let me just change this here. So sine I is because my R's and my I look the same. So sine R now. So sine R, so I just change the columns, doesn't matter. What matters is the graph, right? So we're going to clear out this. Sine 10, 0.2. So you see this number, because it's 5 and up, is higher than 4. You can bump up this number to 2, right? And now we're going to do sine 30. Sine 30 was done here, which was 0.5. And then we're going to do sine 50, which is 0.8. And then sine 70, 0.9. And then sine 90 is 1. So see, everything had one decimal place, so we just follow suit with that. And now that we have done this, it's time to do the lab. So, not the lab, the graph. I keep saying lab because every time you do these things, it's always after you complete a lab. Sorry about that. But anyway, moving along, it says complete table 1 by calculating the values of sine R and sine I. That will give us 5 marks. Okay? So each of them a half mark. 1, 2, 3, 4, 5. So 5 marks. Each of them would be half mark given. In CXC that I don't give half marks. It's give a whole mark. But when I mark it, I'll give you half mark. Now, using the calculated values in table 1, plot a graph of sine R against sine I. So whenever you see one before the other, you know that, and you just know. So Y is the one being judged, the angle of refraction, the angle of refraction is being judged, and this was the angle that was being changed, right? So every time you change it, you are judging this angle here, okay? So this is our x. So anything that is being judged goes on the y-axis, and anything that is being changed so that you could get a judgment will go on the x-axis. And this is known as the dependent variable, and this is the independent variable. So anytime you have one before the other, it's always y against x in physics, okay? Good, so let's get started with the graphing. Ready? Okay. In this moment right now, you'll be seeing the graph on the computer. Well, not the graph on the computer, but the table on the computer, so that you could follow easily. So right now you would see the table on the computer, and let's get started. So the question said to graph, you have to graph R against I, okay? So graphing R against I, remember I told you sine R would therefore go here on the y-axis, and sine I will go on the x-axis. So let's start calibrating for y, and the parameters go from 0 to 1, and it's all points. So we can say, let's see, 0, 0.1, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Good, so this is good. So this is, you can have 0 right here, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going up in increments of 0.1. So each time we move up, we add in 0.1. So add 0.1, you get 0.2. Add 0.1, you get 0.3. Add 0.1, you get 0.4. Add 0.1, you get 0.5. So you see equal increments. Just because you have 0.2, then 0.5, you can't say, I'm going to start the graph with 0.2, and then my next point is going to be 0.5. And then my next, no, you can't do that. You have to calibrate. Calibrate means that you must equally space it based on an increment of whatever you choose. It could be 2s, 5, 10s, but I chose 0.1s because of how the numbers run. So 0.6, 0.7, 0.8, 0.9, and then 1.0. And then on the x-axis now, you're going to plot, again, it's all in 0.1, so you could do 0.1, 2, 3, 4, 5, 6, 7. So this is good too. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and then 0.7. So this is good. So when sine R is 0.2, it is 0.1. When sine R is 0.5, it is 0.3. When sine R is 0.8, we move into 0.5. So easy that this graph is. When it is 0.9, we have 0.6. And when it is when it is 1, let's see. Okay, so and when it is 0, when sine R is 1, you go across here and you look for 0.7. So move up. Right. And it looks like we have achieved a straight line graph. If you look at it, if you could see it clearly, you could find a best fit line. So you could turn it this way and we find a best fit line. So you could see, right? So here now you'll find the best fit line, and what you would do, you would pass it. It doesn't always have to pass through 0. So you look for your best fit line. You make sure that the ruler is placed equidistantly between all of the points. And that looks good, except for this piece here. I lost my foot in. So this is about 1 space away, and this is about 2 spaces away. So yeah, kind of good. All right, so now we're gonna find 2 points on the line and make sure that the line passing between 2 lines on the graph that intersect. So we find 2 points on the line here, and you always want to make sure the points are outside of all the points that you would have plotted, right? And this is another point right here. Okay, and so this, so let's go back to how it was. So this now will be my y1. I have to look, this will be my 1 point, my point number 1, and I'm gonna try to solve for that. So this between here is 1.1. So to find out what the points in between here are, you would say 1.1 minus 1 equal to 0.1. You count the spaces, which is 10 between here and here, and you just divided by 10 will give you 0.01. So because we are 9 spaces at 1, 2, 3, 4, 5, 6, 7, 8, 9, we multiply it by 9 and we add it to this number, the one that's lower. So plus 1.0, and you get 1.09. So that's our x coordinate, 1.09. It has no units. And then for x now, we see that it falls right here. So we know that this will be 0.8 right here. So we do the same thing. We'd say 0.8 minus 0.7, 0.1 divided by 10, because it's 10 spaces, 0.01. And because this is 1, 2, 3 spaces away from this, we multiply it by 3 and we add 0.7, and so it's 0.73. So this is 0.73. Okay, no units. And then the same thing goes for here, in between here. So we know it's 0.01, and this is 0.05, so 0.15. Right, so we say again 0.2, do it, 0.2 minus 0.1, 0.1 divided by 10, and then we know it's 7 spaces up, so we add 0.1 and it's 0.17. So we say that y2 is equal to 0.17, and x2 will be equal to, we do the same thing here. We say 0.1 divided by 10, 0.01, and then we multiply. So we know this is 5, 6, 7, right? So times 7, so 0.07. Okay. Alright, so now we have to find the gradient. So we have all our points here, and I always advise people to write your points on the graph. So to find the gradient, all the slopes, so slope is the same as gradient. You just find the difference between y1 minus y2 over x1 minus x2. Or you could do it the other way. You could do y2 minus y1 over x2 minus x1. Alright, and if you do it both ways, you get the same thing. So we're going to put in our numbers now. So it's 1.09 minus 0.17. We don't have any units, so we don't worry about units because the relationship is probably is a dimensionless quantity. So dimensionless quantities do not have units. And the other way around will be 0.17 minus 1.09 divided by 0.07 minus 0.73. Okay, and once we calculate it, we're going to get the same number. So here we have the calculator. So use your brackets, people. If you don't use your brackets, guess what's going to happen? Yeah, you're going to get it wrong, and then you're going to want to cry. And you're going to wonder, why is life tough on you? And I'm just going to tell you because you didn't listen to Miss Blondell. Okay, so the answer is 1.4. So we're keeping with the 1 decimal place as we had before on the table. And if you do this over here, it's the same thing. 0.17 minus 1.09 divided by 0.07 minus 0.73, and the same thing, 1.4. So you should be proud of yourself if you got these answers. Okay, so that is our gradient. Now, if you do the gradient to the graph, again, at some different spot, which is probably going to happen to you right now, you should get this answer, close to this answer. Okay? You should get close to this answer. I don't know if I could accomplish that because I'm running out of time on my camera. I really don't want to delete any more precious videos. But this is what you have to do the completion in terms of finishing your triangle. Make sure you have your lines drawn. Here. Put your arrow. And then make sure you have your line drawn here as well. Put your arrow when you finish drawing the line. Alright? And don't forget your graph title. So you could say graph showing the results or the relationship between sine R and sine I for light traveling from glass to air. Great. Or you could just write sine R versus sine I, but this is much better, and you could always underline it in the end. I'm running out of time, folks. All right, good night, and I hope you got this while you were doing it along with me. Keep up the good work, keep on working hard, keep on trying, keep up to date with me. All right, don't forget to subscribe. See you later, and let me know how this goes. Bye.